Alright, so we're talking about today, we look at classifying sedimentary rocks. AJ, I want to make sure you're taking notes with us today. We break down sedimentary rocks into three types of rocks. Now, on Friday, we spent a lot of time talking about clastics. So that is probably our, the majority of sedimentary rocks are grouped into clastic sedimentary rocks. Again, what does it mean to be a clastic? Okay, so back to Friday. What does clastic mean? Look at your notes from Friday. Pieces of rock. Okay, so clastic sedimentary rocks are just pieces of other rocks. So we take, and actually, what's kind of neat about classic sedimentary is you can actually take an igneous rock and break it down into a different type of rock, which can then be broken down further into a different type of rock. So we have these progressions and these cycles. Okay, that's kind of leading us into tomorrow's lesson. You can transform rocks to create new types of rocks. Okay, so that's plastic. Now your chemical sedimentary rocks, they basically are formed through a type of chemical weathering. So chemical weathering creates your chemical sedimentary rocks. An example of that would be limestone is an example of chemical. Actually, no, that is not true. I'm not going to go with that one. Limestone, although limestone is actually organic sedimentary rock. And what does it mean to be organic? It's what?
Grown natural.
Well, yeah, all
Or it's natural, it's not.
What does it mean to be organic?
It's not fossil.
It grows in nature.
Natural.
No.
Organic using the natural resources.
Okay, it's heavily from like the green movement of eating organic fruits and vegetables, and actually walk into what does organic mean from a scientific point of view. What does it mean to be organic?
You completely made it out of natural resources.
Not natural. What's the difference between organic and inorganic? Both things are naturally made. What makes it organic?
Not having chemicals.
Or living things. Again, organic. Organism. Okay, made from living things. So sedimentary rocks are made from living things. And if it is, that makes it sedimentary rock. So that's why limestone. If you want to think about limestone, have you ever gone to a fresh lake and you find those itty bitty shells? Okay? Now, imagine the amount of shells that it takes to create a single limestone rock. Because that's basically what limestone is. It's made from the remains of living organisms. And we'll get to that later today. So what I want to do now is take a look at our classic sediments in more detail. So remember, we talk about classic sediments. Again, this is the most common type of sedimentary rock. That's worth noting. The most common type of sedimentary rock is classic sedimentary. And that's because we get this abundance of loose sediments. Because if we don't have a whole bunch of loose sediments, you're not going to form a rock. If you take a pile of sand and dump it in your backyard, that will not create a rock. You need to have a tremendous amount of loose material in order to form a rock, and you need it over a wide region. You're not just going to form sedimentary rock within a very narrow area. Okay, so it needs to be widespread. You need to have lots of it. And then what we can do with these sedimentary rocks is we then further classify them based on their grain sizes. So what does it mean to be coarse grain?
Really hard and rough
Okay, coarse versus fine. What's the difference between the two
Mine
sizes?
is easily broken.
No?
Fine is more powdery
So
And,
it's smaller.
and coarse is more chunky. And
There we go. So your coarse is a coarse size gonna be kind of relatively large size grains or granules. Okay, mostly pebbles. Now I'm gonna ask you to think for me a little bit. When we think about coarse size or coarse grain plastics, what I want you to do, I'm gonna show you two pictures up here. I want you to study the pictures. On this side we have breccia. On the other side we have conglomerate. Okay? Now, study the picture. Look at their grains. Look at the pebbles. Compare and contrast. Take 1 minute to do so. Alright, so let's have that discussion. What do you notice about the grain shapes in breccia versus in conglomerate? AJ.
breccia has many different types. What it looks like, it has more types of stuff.
Okay.
Than
Alright, that's a valid observation with these two samples. Good. What else do you guys notice? Nobody sees anything. Is that what you're telling me? Go ahead, AJ.
Conglomerate looks like it could be fine, and the other one can be coarse.
No, they're both coarse. Zach? Not really. It's not so much, because the key word here is shapes.
One's flat,
If you look at your breccias, what do you notice about each one of these shapes? Well, that's because you're looking at it from a side view, but they're blocky, right? Sharp edges. Okay. What do you notice in the conglomerate? Okay. So all these are rounded shapes. How do you get rocks to become round? You got to roll them, or either that or have material roll over them, right? So what if I told you that these are both created in water? What does that tell you about breccia versus conglomerate? Brandon?
Conglomerate looks like it would get hit inside a rock.
Kind of.
Breccia has a weaker ripple to it because of the time, and it's going to cause it to roll out.
Maybe not so much weaker, but what about the time? What about time? How does time factor into this problem?
Breccia looks like it had more time back.
Now, again, we're not growing crystals. That's igneous rock. In this case, we already have the setup for gluing them together. Which one spent more time in the water? Why the conglomerate?
Because it's been rolled more, so it's more.
There you go. So the big difference there between these is that even though they're both created in water, the breccia has spent less time in the water than the conglomerate. And that's because the conglomerates are nice and rounded pebbles, so that tells us that it's been rolled more, it has been smoothed out more by the water, whereas the breccia, even within the same water environment, the breccia basically shows us with the square-shaped granules, tells us that it's not had as much time to become eroded away or smoothed out. And the next type is grain classes we're going to talk about are medium and are mediums. And with the medium, okay, that's mostly your sand and other types of minerals. Okay, so for example, this would be sandstone. Krieger, pay attention. And so a lot of your medium grain clastics do tend to become sandstone. Where do we typically find a lot of sand? Beaches. Where else?
lakes.
Okay, so lakes, riverbeds, deserts. Those are your main four areas, right? So beaches, lake bottoms, river bottoms, and deserts. So think about your region here. Suppose you went digging around and you start finding this humongous sand deposit in your backyard. What does that tell you? Not necessarily.
It used to be an island.
Used to be an island. Not a bad approach. Anybody else?
It used to be sand.
Okay, there we go. We know that we had a lot of sand there at one point. Think about, what do you guys know about our region's geology in the past? What is one of our greatest
Glacier.
glaciers? There we go. And in fact, we're actually pretty far from one of the most recent moraines, which tells us that the sand, being although heavy but still pretty light, traveled quite a ways down from the glacier. Especially, we're in a region right now where we got a lot of sand deposits. So that's something to keep in mind with that. So like I said, you just gotta know what the rocks are telling you. Remember we talked about ripple marks getting trapped within the sand? Right there's a perfect example of that. So you can see how that kind of ripples. Not only that, but can you tell what direction the water was moving?
Down.
Was it going down or was it going up?
Down.
I would say it's probably going in this direction. Because it looks like it's a little sharper on the bottom side than on the top side. There's one more thing I want to talk about here before we take our small break from this, and that is porosity. A lot of times in your classic sediments, you have a lot of porosity. And again, what does that mean? What does porosity mean? Okay, you ever heard of the term porous before? You guys ever heard of the term pore space before?
I've heard of porous is that's what SpongeBob is.
Yeah, porous means full of holes. Okay, so that's what porous means. To be porous, you're full of holes. And SpongeBob is full of holes, so he's very porous. Yellow and porous is he, right? You guys don't look at me like I'm a crazy person. You
No,
guys
I
want-
just said something earlier. It's just
So anyways, porosity is basically the degree, I guess rather the amount
is that
of air spaces, also known as pore spaces. And so I know we saw the same thing on Friday, but we're going to see it again. Right, we're looking here on a beach, but when you zoom in and you look, okay, there's actually a lot of air spaces in there, so a lot of pore spaces, and then those pore spaces start filling in with the crystals. Okay, so we'll watch that again. So we have the pore spaces. Okay, so one more time, here we go. So all the blue that you see in there, those are the open pore spaces that the water filters through, and eventually as it dries out, the minerals that are within the water start to evaporate, and then they start to actually become the glue that holds all the rock together. Right name.
what does it say degree on
Degree, or the amount of air spaces, also known as pore spaces.